So, linear modeling. Using everything we have learnt regarding... Yes, they can hear you. Guys. Shh. Right. Using everything we have learnt regarding linear equations, so everything we've learnt regarding linear equations, that's all of chapter 6. So that's, if I could go back, that is all this stuff that we've done here previously. So A, B, C, D, all the way to H. And then keeping back down to I and J, we can solve a variety of different problems using linear tools. So by combining all we know about the gradient, combining all we know about distance, midpoint, all of those elements, we can solve different elements of equations and find these questions, okay? So let's remind ourselves of what we've learnt. Let's remind ourselves of what we've learnt. So, we've got the gradient intercept form of a straight line. So let's remember, guys, the gradient intercept form of a straight line is y equals mx plus c. Probably touched on this last term that all lines are usually written in this form, mx plus c, m being the gradient of the line, and c being the y-intercept of the line. The gradient is equal to m. We use m for gradient just because we don't use g for gradient. G is known for gravity. We don't want to mess that up, so we use m. And m is equal to rise over run. Rise being the change in y, so my y2 take y1. And my run being my change in x, so my x2 take x1. So that is how we find the gradient. The y-intercept of a line will always be c. The y-intercept is always c. Remember when we were doing sketching with intercepts yesterday, that number at the end, that c in our line, will always be that y-intercept, okay? If we have an equation 2x plus 4, the y-intercept is 4, it's always going to be c. If the y-intercept is not obvious, and when I say not obvious, I mean it's not written in y equals mx plus c. Some equations will be written differently, which we'll touch on a bit later on, but you can just substitute x is equal to 0 to find the intercept. Substitute x equals 0 to find the intercept. Now, there are also two more elements we should probably talk about, and that is vertical lines and horizontal lines. Remember, if we have a vertical line that's just going straight up, which means it's not moving left or right, vertical lines have an equation of x is equal to k, and k is the x-intercept, because it cuts the x-axis at that vertical point. Intercept, I'm just going to write int for intercept because I'm lazy. And then a horizontal line has equation y equals c, and c is the y-intercept. So horizontal and vertical lines have those different elements to them, and just be aware if you cross them in problems what you're going to have to do. And now we can use all of these tools and all of these rules that we've learnt to model certain linear equations and model linear problems. And we can use these to help us solve different types of questions that they're going to be asked. Some might be more wordy than others, some might not be as wordy as others, but just like combining everything we know. And we're going to get into a couple of examples of what each of those are. Is everyone okay if I scroll down to there? Yep, cool. So, for my first one, it's just going to be for the straight line, which I'll draw in a sec. For the straight line, determine, and the first thing I want to find is the gradient. The second part will be the y-intercept. And lastly, we want to try and figure out the equation of the line. Equation of the line. And I'm going to draw my line now. And then it's going to look something like that. And then I'm going to have a point here, and I'm going to have a point here. That's going to be... Now, this obviously isn't to scale, so please don't... But they're my 2 points, and I need to find the gradient of the line, I need to find the y-intercept of the line, and then I need to find the equation of the line. Alright, Joseph, yeah. How am I going to start trying to find the gradient?
Good question. Do you put them like above each other, like y1 plus?
Yeah, let's start with the formula. This formula is a good place to start. So we know that the gradient is equal to y2 take y1 over x2 take x1. Now, it doesn't matter which is your 1 and 2 in this question. It just, like, you can pick 1 as 1 and 1 as 2, but just make sure you don't swap them around. So let's just call this one 0.1 and that 0.2. So now if I ask you guys, what is the y coordinate at my second point, what's it going to be? Tate. That's my first point. What's the second point? Yep, and so what's the y coordinate of that one? Remember, all points are written as x, y. 11. So it's 11. And then the next one's going to be 15. So 11 take 15 over 3 take 1. That's going to be negative 4 over 2, which equals negative 2. So we know that my gradient is going to be negative 2 for this line. Another way you could do it, if you didn't want to do it like that, is just do it from the graph. 15 to 11, I've gone down 4. And then 1 to 3, I've gone across 2. That's my rise and that's my run. You can do it in both ways, it doesn't matter. They're going to get you the same answer. So, now we need to try and find the y-intercept. Does anyone have any ideas where we will start trying to find that y-intercept? You're all so talkative today. Alfie, you have any ideas? How to find the y-intercept? Nope. Well, we know we can write my equation of the line in gradient intercept form. So let's just start by that. We know the gradient now is -2. So I can say that y is -2x plus c. I know that has to be true because the gradient is -2. I just don't know what the intercept is, so it's not a complete equation. But how can I figure it out? What information have I been given already that will help me figure out what c is? One of these points here. I can pick either one of those points, and I can put it into my equation, and that's going to help me find c. So let's just choose this one. I'm going to drag it along. And I want to put that into my equation. So 3 is x, 11 is y. So now I'm going to write it as 11 is equal to -2 times 3 plus c. Jordan, what's -2 times 3? What's 2 times 3? Yeah, -6. So 11 equals -6 plus c. And then I'm just going to plus 6 onto here. So 17 is equal to c. So now I know that my y-intercept is 17. I know my gradient is -2. The y-intercept is 17. Okay, Jeremy, what's going to be the equation of the line if my gradient is -2 and my y-intercept is 17? So remember, all equations are written as y equals mx plus c, right? What's the gradient? So -2 is going to be my m. And my y-intercept is c, so that's just going to be 17. And that's the equation of the line. So we were given 2 points. We all know, because I've said it a million times, the minimum you need for a straight line is 2 points. You found the gradient using those 2 points. Putting one of those into your equation, you found the y-intercept, and then you have the equation of the line. Stock standard linear modeling question. It's also going to be a stock standard question I would expect you to see in your exam, which at this point is going ahead.
But all of the other teachers saying they're not.
Don't believe them.
Okay.
Yep.
Go 6 against 1.
That's, where'd you get the -2 and a 3 from?
No, it's not A plus 2.
Sorry, y equals -2x plus c, right? Because we got it from the gradient. I got the 3 because I took the point from here,
Yeah.
and then I substituted it in.
Instead of x.
Yeah,
Alright. And then you got 11.
11 because that's the y coordinate.
Oh,
Yep. Okay, last one.
No, because it's like the same thing. It's like 2 times 4 and 4 times 2. Is that how 2 times 4? So it is A after 4 times 2 is A.
So thank you guys. An employee gets paid $20 plus 10 for every hour worked. If he earns C dollars for 2 hours, for T hours. So he works T amount of hours, he earns C amount of dollars. Find, we'll go A. A is going to be the rule. So remember, a rule is something that relates two equations to each other in some sort of pattern. So we've got two variables, we've got C and we've got T. C is the amount that he earns, C is the amount that they work. So if I want to try and find out C, C being the cost, how much they make, well, how am I going to determine how much they make for however many hours that they work? Who has a job here? Who has part-time work? Sam, how much do you earn per hour? $9.13, okay. Let's just say it's 10. Because let's just say you earn 10 per hour, because we're just going to round that up.
No, you said 13.
Oh, 13. Oh, man. I did not earn that much when I was your age. I earned $8.37 when I started my job. Hungry Jacks.
Same. I work there, sir.
We've discussed this, Joseph.
Do you get paid that?
I get paid like 12
Yeah, 1995. Yeah, exactly. No, I'm joking. Don't worry. Okay, anyway. Yeah. So if you earn so much money per hour, right? If you work 1 hour, you're going to earn $13. If you work 2 hours, you're going to earn 26, 13, 39, so on and so on. You're just multiplying it by every time your hour is working. So if it's 10 per hour, it's going to be 10T. Because you're just multiplying your amount per hour by how many hours you work. But then what else do you also get paid?
Overtime.
Not overtime, more in the question that we've just asked. What does it say first? They earn $20 irrelevant. No matter how much they work, they get paid $20. So you plus 20 on the end of it. We're not working on the weekends. We're just normal rates. So the rule to find out how much they earn is 10T plus 20. Now let's sketch the graph.
Please stop talking.
We want to try and sketch the graph for this rule, okay? So we're going to draw, and it's going to be a very, very rough sketch. Doesn't have to be amazing. So we've got the cost is my vertical axis, my time worked, my hours worked is my horizontal axis. Looking at that graph, that C equals 10T plus 20, where should I be cutting that vertical axis? Where should that line be cutting my vertical axis? At 20. Because 20 is the intercept. It's that number at the end. What, sorry?
I don't know.
Okay. So we started at 20 there.
Oh, yeah.
And then every hour you earn $10. So let's say there you're going to be 30, 40, and you're going to go up and up and up. It's going to look something roughly like this. Okay, and you're going to get more money the more you work. So we're going up. C. How many hours did they work? How many hours did they work? If they earn $180. So if they earn $180 for how much they worked, we need to try and figure out the amount of time that they worked. Does anyone have any ideas how we're going to figure that one out? So we're trying to find T, but how are we going to find it? Dividing by 10 is probably on the right track. Let's just remind ourselves of our equation, right? So C, the amount we earn, 10T plus 20. Okay? That just determines the amount we earn for any time spent working. Well, do we know the amount of time we worked? Do we know the amount that we got? And what's that?
So divided by 10 minus 20.
Divide by 10 minus 20. We say that 180 is equal to 10T plus 20. And then it's just a matter of solving the equation like we normally would. You take 20 from here. You take 20 from there. So 160 equals 10T. 16 equals T. And so he's worked 16 hours. Now these questions are they can be related to a different number of situations. There are many types of linear examples that we have just in real life. Pay rate's a great one of them. And so there's probably going to be a common example you see in questions. Now we're just moving on to the exercise. The questions are up there for you guys, so go for broke.